My name is Constantina and I am excited to announce the 2019 UCL Mars Rover. We are a new team of interdisciplinary undergraduates from mechanical and electrical engineering, computer science and natural sciences. This year we have expanded our team to 22 members as well as a diversity of STEM backgrounds. We have worked hard on developing a new robotic arm, science gas, and a new autonomous system and control system. The team is divided into 6 sub-teams that are aligned with the tasks of the competition, with each sub-team tackling specific challenges.
Our suspension uses a rocket bogie mechanism, which involves a shock absorber through a differential bar. This allows us to meet the dynamic loading requirements by the URC tasks. The arm and drill are to be housed securely within the chassis, both during operation and in motion. Our current wheels are made of fiberglass rims and strips, providing both traction and suspension, while remaining lightweight. We are also currently experimenting with balloon tires as an alternative.
This year for our new robotic arm design, we are using a system of linear actuators and motors which enables us to have 5 degrees of freedom for our robotic arm. With the use of our custom aluminium sheets and 3D printed parts, we are able to get a net weight of 9.5 kilograms, which is an almost 25% improvement to last year's design. For the gripper mechanism this year, we are using screw system, which not only enables us to have better reliability, but also enables us to maintain better accuracy for the system. Our robotic arm this year has to perform many challenges, such as lifting 5 kg weights with handle diameters of 5 centimeters, tightening and loosening screws with a screwdriver, typing on keyboards, etc. We have optimized our gripper and arm design to ensure the best results in all these challenges.
The implementation of the robotic arm control system is completed in 2 stages. We first use Arduino to ensure we have a robust power and drive system for the motors and actuators on the robotic arm. We then reconnected these onto an NVIDIA adjacent TX2 module, where we were able to use robot operating system and move it motion planning framework to achieve real-time control of the robotic arm with 6 degrees of freedom.
The UCL Mars Rover uses an autonomous planner running on the Pixhawk system based on the Arduino Rover firmware package. An extended Kalman filter is used to combine position estimates from the inertial measurement unit and the GPS receiver, which subsequently inform a SLAM planner running to avoid obstacles on the way to a GPS location. At the GPS location, we then turn on the Z camera, which uses a depth detection algorithm and optical object recognition using the YOLO neural net in order to detect the tennis ball and move towards the final endpoint. In order to detect obstacles along the route, a series of Automotive-Grade Radars operating the 77 GHz band are used. These sensors are able to detect a target of 0.5 meters squared RCS, approximately the size of a toddler, whilst travelling at up to 70 miles an hour at ranges of up to 80 meters. The rover communicates with the ground control station across 3 separate radio links. The main telemetry link is provided on a 433 MHz channel. This is used to relay all the major telemetry data from the rover to the ground control station, as well as to pass waypoints and other commands directly to the Arduino Rover system.
For our science system, we decided to use a lifting mechanism because of the accuracy of the auger when we dig underneath the ground to collect soil. The auger collects samples of soil, which then passes through the filter and is mixed with solvents before dropping it into the test tubes. These test tubes are placed in a rotating plate where on one side a spectrometer is used and on the other side dyes can be added.
We hope to find either materials, like limestone, or structures, like fossils, that indicate past or present life. The soil analysis starts with basic tests, like pH, humidity, conductivity, and temperature. These tests are important to look at the chances of finding life, but also for our main test, UV light spectrometry. Here we will look for structures in the absorption spectrum that indicate life, like NAD, carotenoids, and flavids. To make it easier to analyze, we will also use some fluorescence dyes for nucleotides, fats, and one dye that indicates enzyme activity.
We have showcased the rover at various events around our university to fellow students and teachers. On the opening event of the new UCL Student Center, we demonstrated our rover, which has impressed investors with the innovation within the UCL Rover chip. On the mechanical engineering night, our rover has performed by offering a flower to the Dean of Mechanical Engineering Department. The rover has had a good influence on promoting engineering innovation and creativity around the college.